In the wording for problems, you might look for the probability of one event or another event. The keyword you want to look for here is or. If you're looking for two events and they're connected by the word or, you're most likely going to want to use addition of some sort. Now with the addition rule, there's kind of two forms that it can take. They're very similar, but what we need to know is, do the events overlap or not? So if we go back to our jelly bean example where we have these 10 jelly beans and 1 blue, 2 purple, 3 green, 4 red, and let's say we want to look at this probability of purple or red. And in the previous video, we did do an example with this scenario, but let's talk about it a little further. So if we want this probability of purple or red, again, what we're saying here is that with looking at these two colors, we could have one or the other. So we could have just purple or just red, that works fine, or both. So if there were jelly beans that were both purple and red, we'd want to think about those as well. In this scenario, though, there isn't this case of both. We don't have jelly beans that overlap. And when we have this case where the both scenario doesn't exist, that means these two events are disjoint. And that's going to be something we want to look for when we use this addition rule, because it will change the calculation ever so slightly. So disjoint events are events that cannot occur at the same time. So in this case, we can't have one jelly bean that's both purple and red. So there's no common outcomes. Like if we're working with chips, it can't be green and black at the same time. Another word for disjoint is mutually exclusive. They mean exactly the same thing. So if you see that two events are mutually exclusive, that just means that they're disjoint. So what that means is that then in terms of this probability, we want to think about adding, because basically what we want for our numerator is we want to think about these 2 purple jelly beans that can occur and these 4 red jelly beans that can occur. So if we're drawing a single jelly bean, there's 6 cases that match this idea of purple or red. So in our numerator, we'd have 6 out of our 10 possible outcomes. So this would be a 0.6. Now, in terms of calculation, to really break it down in terms of what we did, what we ended up doing is adding the 2 probabilities. We really took this probability of seeing a purple jelly bean and added that with the probability of a red jelly bean. So you can also get this 60% out by taking 2 out of 10 plus 4 out of 10. But it's this breakdown of adding the probabilities that's our part of our addition rule, that you can add the separate probabilities to get our solution of 60%. So this is a case of disjoint events, and we're working with probability of one event or another event. So our rule goes, if A and B are disjoint, the probability of one or the other is just the addition of the separate events. So let's say we want to look at the probability of blue or green. What we could do is take the probability of blue plus the probability of green. And so then you can think of them separately. So probability of blue was 1 out of 10. Adding that with the probability of green, which is 3 out of 10, which would be a 40%. So that's our addition rule for disjoint events. So let's say we had a table. Instead of being given probabilities in words, say we have this table that we're looking at, and we looked at this back with categorical data. So what's the probability that they were given desipramine or lithium? Now, with the table, to determine whether or not it's disjoint, basically it'll be disjoint if they're both columns or both rows. So for example, disjoint events, relapse and no relapse, those are disjoint events because they're not going to overlap anywhere. You can't have one person that is both relapsed and not relapsed. They can only be one or the other. Then your other disjoint events will be the different drugs that were assigned. So despermine, lithium, and the placebo, those are all disjoint events because you can't have one person that took both placebo and lithium, or both lithium and despermine. So this case that we're looking at here is disjoint because there's no overlap. In terms of the graph, that makes sense because at no point are two rows going to overlap with each other. They're kind of running parallel. So in this case, we can just look at the probability of despermine plus the probability of lithium and add them together. So let's see, despermine was 24 out of 72, plus lithium is also 24 out of 72 to get a final probability of 2/3, so 0.6667. So there's a 66.67% chance despermine or lithium. So this is another scenario of disjoint. But this next case of if we look for the probability they had lithium, or, which again, something that I do is when I see or, I draw a little plus symbol over it, because or is going to be addition, one way or another. Doesn't matter if it's disjoint or not disjoint, you're going to be adding things. So that can be a helpful tool to know which rule to use so you don't accidentally use multiplication or another operation. If you see or, you're going to have addition or relapse. Now, in this case, lithium, they're in this group here, and relapse is this group here. Now, this is a case where we do have the probability of both. We have these 18 people that had both lithium and relapsed. So this is a case of not disjoint. So let's see what happens if we start applying the formula for disjoint events, the formula that we've already been using. So taking probability of lithium or relapse. So in terms of how we write it, it's exactly the same. We don't really see from the notation that it's not disjoint. It just comes through in the calculation. So say we start applying our old rule. So we take the addition, which would result in, let's see, probability of lithium, 24 out of 72, plus for relapse, 48 out of 72. And let's go ahead and throw that in the calculator and see what comes out. And it would actually give us 1 out. It would give us 100% chance. But what we can see from the table is that that's not true. There are these people that we're leaving out, specifically those that didn't relapse, that weren't taking lithium. So this formula isn't working. And why it's not working is because what we did is we took everyone who is taking lithium. So we have all 24 of those people, those that both relapsed and didn't relapse. Then what we did is we added those that relapsed, and then didn't matter which drug they were taking, despermine, lithium, placebo, we added all those together. So what ended up happening is we double counted in one spot, and it happened right here with those 18. They were counted twice. When we took lithium group plus relapse group, that overlap was double counted. So what we need to do is when we carry out this addition is we are going to do this addition as if it was disjoint, but we have one little extra calculation to throw in, and that's to subtract out this probability of both, because we counted it too many times. Basically, you only want to count it once, so if we take it out once, that's perfect. So we want to subtract out 18 over 72. So then that will give us a value of 75%. So when you have non-disjoint events, there's this extra step here of subtracting the probability of both. So this is where the formula is incredibly similar for the two. It's just when they're not disjoint, you have to think about that overlap. So the formula here for non-disjoint events is going to be probability of one event or the other. You still add the probability of the two, then you just have to take out the probability of the overlap. And that's our addition rule.